All right, we are set. Um, Talk today is on a very high-priced title, N-Way Extensible Locator. So we'll detail what that all involves. So to get started, what is a locator? Title in our talk, how can we use locators, and what are the forms they can take? That will be what we shall address. And also, this is drawn heavily from Win32 4, the technique it uses for error messages. So the structure of a locator, or the whole summary, is that locators select information using a number. You give it a number, it will find some relationship to that number and pass it back to, in this case, the fourth stack. Locators are located inline in the dictionary. They are essentially a fragment. They are somewhere, say, of 20 or 30 bytes of code inline in dictionary, and their only identification or linkage is through their identifying number. They don't show up, they don't have a name, they don't have a word, they don't show up in a dictionary list. They simply consist of a one-cell link. This is a series of address pointers, as we'll see. There's a discriminator, which is the thing that identifies this particular locator, its unique identifier. In this case, it's one cell, so that's 32-bit, so the discriminators can be extremely large. That's the discriminator is followed by the payload. That is, what do we wish to find or locate? Generally, it's text, but it could be a pointer to somewhere else. It could be code. It could be a file name. Here's some examples of what the payload could be. Very often, you get a string in exchange for a numeric code. In the American National Standard for fourth, they specify error codes. They don't give you the actual values, but there are about 30 or 40 conditions that can result in an error. And so a very typical one is stack underflow. And in Win32 4, it's assigned the identifier -4. The payload could be just a compiled CFA. We'll later see an example how that is done, so that a numeric sequential identifier could be used to extract a CFA to find some code. For example, in a very simple database, the identifying number could be an employee number, and it just links to the name of that person. Or another one is it could be a file with a complete path name from a number. That's quite a general use. You could give files numbers. Every time you access a given number, you will get the search path and the file. Here's the code that generates the link. It's extremely simple. It's surprising how simple it is. It essentially just handles two links. It creates one and it places one. So link comma, you just give it a source address, which is a variable. So the variable points to this chain of addresses. With here over fetch comma, you have now compiled inline the current address of the pointer chain. With swap store, you now have placed the address of here back into that top level pointer. So we have the top level pointer address where all the links originate, and we have now just linked the location here into that chain. Nothing else. We've written a pointer and we have located the pointer. And that's all it takes to make the process work. Here's an example of what the compile structure looks like. It's at a memory address, as we see, 449AB0. And the first 4 bytes, 949A4400, is the link. And that is a forward-pointing link to the next word. Every link that's made, every word that is added to the link is backward pointing. These structures are created in sequence going forward, And so you know the latest location, and then it links to the priors. The second field, 650000, is the discriminator. In this case, it is the hex number 65. So if you put into the system hex number 65, you will then get the following address. And this is a counted text. As you can see, the count is OD, that's 11. And the text then follows the 46, 6F, 75, 6E. And in this case, the message, the payload is found message. Let's look at the code that we use to find this. We give it a search address, and what comes back then is the found address and a true flag. So after the search is made, when we get a match, we will get the address of the match, and we'll get a true flag. If no match is made, we'll get a false flag. Makes sense. So I've assigned it the name .search. The input parameters and address. N is the value we're searching for, and ADDR address is the starting point for the chain of structures. So it's a simple begin a loop. We begin, we fetch the start, we run down through the link, test the first link. The zero equal says, did we get a match with the first link? If we did, the nip 2 cells plus true exits with a true flag with a match. If we fail to get a match, we then just do the dupe fetch zero equal, and that walks us down one level of the chain and says, pardon me, it rechecks this discriminator and says, is it 0? If it's 0, we're at the end of the chain and we return with a false flag. Otherwise, we've gotten no match and we've gotten no exit, so therefore it loops back to again. And we just blithely run down that chain of addresses. So again, we're either going to exit with a true flag and a location, or else we're going to exit with a false flag. Here's the search routine used in an application. Now we want to find a message. So my .message again starts with the end locator and then the address of the start of the chain. We execute that .search, and as we know, we're going to get back either a true flag. So if it's a true flag, the if will execute, and we have an address on the stack of the payload. Count type will display it. Otherwise, in the case of a false flag, we just put out the message, no message found. So again, a very simple locator and a very simple message display. Here's the application or a use of the creation of the list. We start with a variable called myList, and we execute myList off, which zeroes out the contents. So the contents of myList is now 0. The pointer value is 0 in the contents. Now we will start to link messages in. So we go back to myList. Again, we execute that simple little routine link, which now has made here the current link value. 999 is the locator. We comma that in place. That's our locator. And then we compile in line with a dot quote that we found the message 999. So after we found 999, we should get a message that confirms we did find 999. To place the next message, again, we say my link, which is the origin. And now link comma will go from the most recent, from the entry in my list and create a new linkage, and it will then be linked automatically to the one that was just above. So the 101 message will link back to my link. Pardon me. The my list points to 101, 101 points to 999, and 999 contains a 0, which will stop searching. So we now have created 2 messages. So let's execute. If we execute the code 999, we give it the starting point in the list, my list, and then dot message, we will see it found message 999, and that is what happens. If we give it the second locator, discriminator, 101, execute my message, and it will come back. And yes, we did find 101. Now, what if we give it a locator that's not on the list? So we'll just pick at random 111, run it through the my message, and back we'll see no message found. So it is very well behaved. The linkage is clean. The linkage is very fast. The linkage from word to word is only about execution of about 4 or 5 fourth words. Very, very fast. Let's try another one. We're going to create a structure to find words to execute. We're going to we're going to have the payload in this case is going to be the pointer to actual machine code. In this case, the search is done similarly. We use .search to search the chain. Upon a match, we just fetch the payload and execute it. Otherwise, again, we execute no code found. So very simply, we run down that chain until we get a match, grab the next cell from memory and execute it, and then forth we'll continue. So let's show an example of putting that together. First, let's define some words. So we're now defining 2 words. One is EX999, and it could be containing any particular fourth code, but what I've done here is for identification. I've just put in the text message executed 999. We define another word, EX101, and it will give a similar text message. And again, remember the executed words could be any fourth word in an application. This is a pretty simple situation. Now they'll build the list from that. First, we declare the variable myList, and with myList off, it is now reset to 0. Now we compile or generate the links. So we start with myList. Again, we link it down to here. We put 991 in line. And now at this point, we're now compiling the address of EX999. The bracket compile bracket reaches the word ahead in the source stream, finds its code field address, and compiles it. My link followed by link again 101 compiles in line that structure, and it adds in EX101. So we will go through and actually operate it. 991 passed using myList to execute. Sure enough, we see it will go executed 999. It has executed the code we requested. Same way with 101, the code that we requested will execute. And again, the default case of 111, which is not in the list, will give us the no code found. So again, very well behaved. This is how it's used in Win32 to handle the ANS error codes. And in this case, we'll see a little further expansion on this. But one typical use is the minus 373 is the discriminator or error number. Throw messages is the variable at which the links originate, and then dot message displays that. This is the dot message word. Now in this case, I've combined the search and the message into a single set of code. So it is just one word does the search and it does the display. So again, it has the begin again loop. In the middle of the loop are the 2 conditions. The first if is upon a match, and the second if is no message found. Under the first if, we see nip 2 cells plus count type exit. So again, here we are just directly typing the message. So 2 choices at each node. You either find a message, you don't, you loop, and away you go. And this, we will examine its use in Win32. So here's how the ANS standard specifies. It says that if you use the locators of minus 4095 to minus 256, These are for implementation defined errors, and that is inside Win32.4. Its own error selections are done in that range. For the errors that are mentioned in the American National Standard, things like words not found, stack overflow, file unknown, and so on, those are in the range of -255 to -1. A 0 through the system signifies no exception, and then codes greater than 0, those are used in applications. So they are free to be used in application. And of course, the user can also use all of the codes that are already defined in the system. Here's a few examples that are taken directly. I executed this directly out of Win32.4. So with -4, throw messages. We see stack underflow. -14 decimal gives us is compilation only. -16 requires a name. -38 is file not found. And the -280 is an ANS message, create file failed. 281 is read file failed. So we see here's a mix of the internal error messages, which have the low numbers, and the ANSI messages, which have high numbers. And then again, we're free to use the positive numbers in applications. So to wrap it all up, the link, the code, the structure is compact and the code is very compact. Uses are quite general. We've seen 4 or 5 applications. The interesting point on this is there's the aspect of deferred action here, because we can define that variable that is the head of all the messages, and then we can begin to link messages into it. And those messages have not been defined. So in other words, within our code, we can use those message numbers and a search inside the code, and the messages have not yet been defined. Then somewhere late in the code, there could be a declaration of all the messages. The advantage of this is it centralizes the messages rather than them being distributed across the application. This means that if you have a long application, you would accumulate your messages toward the end. And so at the end of the application, once you've got it fully complete and developed, you bring all the messages down to the very end, where they're easy to update, easy to check, easy to verify, and makes your documentation simple. And as a reminder, the internal messages are available and easily used in applications. So as I write an application, I'm working one heavily on matrix data structures, the file presence and missing, and stack messages are readily useful. So do we have any questions or comments? Last chance, questions or comments? I see we're all stunned into shocked silence. Either that's good or bad. At least Brad finds that humorous.
The links are one way. You don't have like going children or parents or anything like that. They're just a linked list.
Yeah, it's a one-way linked list. One could possibly make a easy that link word structure is so simple. It would be easy to make a two-way linked list and search from either end. I'm not quite sure. I'm sure some use could be thought of that. But
I guess file systems and all this kind of stuff are just organized with IDs and stuff, so that there's all sorts of usefulness for numbered IDs, I guess. I mean, file systems included in other things.
the fascination I have with it is that the code for the find word is so short that it's you know you'd say, man, I wish all of the intellectual components of Forth were that simple. So it again, it's ideal for error messages For the other uses are questionable. Another place I think it would be good is if you're doing if you're creating a lot of resident files and you want to refer to them by number from a list or by number. Good way to nail down file names. Um, Also, a lot of times they tend to be. Remember, these could be concentrated at the end of the application. So the value is you've taken all of your search paths and file names and, and aggregated them toward one chunk of the application rather than having them scattered through the application. So it gives you it motivates you into a formal structure. Anything else? I think we have a nice turnout today. I put a notice on this on 4th 2020, and so I suspect we have a number of people coming in for 4th 2020. And thank you for being here. Okay, back to Kevin. Thank you so much
Bill,
for
the
your.
talk you had touted last month for this month, which was Windows shell support in Win32 Fourth. That sounded kind of interesting. Could I impose upon you to deliver that next month?
Yeah, I'll probably so. Yeah, it's as it stands right now. It's modest, so I hope I can build it
It
up. But
it need
it's
not.
it's a very aggressive 5 minutes, maybe. So
I
we'll
think
see
I
next
think
time.
you could probably stretch it to 10 minutes, like by doing a directory and reading the directory into a file and then processing the directory, to make some tool that finds things in the file system or
Well, you're right ahead of me
exploits
now
some other.
because you're right ahead of me because a number of the functions is looking at directory listings.
I'm not surprised. I remember my youth shell scripts were kind of a thing, and I think this was like the DOS era, and I think I had my my shells my shell scripts were all written in Forth back
It looks
in
like Andrew has joined us. So welcome, Andrew. Glad to have you here.
Andrew's a slacker and he's not presenting this month.
We'll work on him.
What are you going to speak about next month and perhaps on Fourth Day?
Well, the only thing I have currently, I'm still working on my Wordle solver, and I got some new ideas in the last week. Um, Constantly polishing the code, so that's what I was going to tee up for Fourth Day.
That sounds
The
awesome.
yeah. Then there was the only other thing is in 2020 I got bored for a while and I wrote another Fourth because what else do I do? Some kind of it's a bytecode interpreter combination of CM Fourth and this Fourth, which are two beautiful fourths. So that may be interesting at some point. I haven't touched it in 5 years, but I don't know. I don't know what's interesting to people
Wow.
these days.
Being feeble-minded, I can't remember. Was this Fourth Will Baden or was that?
Yeah, that was Will Baden. So he wrote a Fourth using M4 preprocessor and had a
Oh
really
yeah.
cool. And the idea from him is take the text of your Forth system as one file, and it produces Forth code and C code or whatever, right? It kind of, and then it puts it all together, and then you compile it. Now you've got a running Forth program from Forth source, right? And I thought that was really clever. And then CM Forth, of course, is clever by itself. So I stole both of those, and it was an interesting journey, and that's
Yeah, my
something to dig
recollection
up someday.
about this Fourth was that it was kind of hard to wrap my mind around it. And I think that many people had that experience. It was,
Yeah, when CM Force was the same way for me. It was like a mystery for a while. It's like, wait a minute, here's the source code, but this is the file. So where does it come from? This looks like and it kind of magically turns from the target host to the target, like kind of slithering. And if you don't notice it, it becomes magic, right? And this Force the same way, right? There's this magic that, you know, but again, I don't know what the what the interesting topics are so I don't know if that may be interesting someday.
yeah, I'm interested to see uh, maybe next month or after fourth day, some kind of getting started with object oriented in fourth. I don't know if that's an Andrew question or a Bill question. Maybe either writing a short document that you can tout in a brief presentation at a meeting, or alternatively just make a more extensive, getting started with the problem that I had with it at one time in the far distant past is that it didn't seem like there was documentation or tutorial or reference material to be had. I guess you needed to figure it out for yourself.
Is that on object programming?
Yes.
Andrew wrote about a 20-page tutorial that's in the help system on Win32 Fourth,
Oh, cool.
and it's quite
Yeah,
thorough.
and there was maybe a fourth dimensions article on it too.
Okay.
Because I implemented it in ANS fourth. That's the one I published, I think, in fourth dimensions. Because the one in Win32 fourth uses some internal stuff, but I wrote a pure ANS version of it, and there's a paper on that somewhere.
Yeah, we like
Many,
to
many years
enunciate
ago.
the individual letters and not make an acronym of it, because otherwise, people could misunderstand our message of A N S.
Yeah, I don't
Goodness.
know what standard fourth. We just say
Right.
standard fourth, and we pretend everybody knows what that means, right?
And we
Well,
pretend it's standard.
I'll always remember Charles Curley's article in a Fourth Dimensions past from the fourth non-standards team, lauding the benefits of a my fourth implementation, that you made a fourth that was your fourth to do your job because it was well suited, and it would be good if the wheel was round this time instead of the oblate spheroid without an axis thing that might otherwise result. But we digress. Brad, is it time for the screenshot?
Certainly. Let
All
me,
right. Now here's how this works. Turn on your camera. If you're hiding from, you're in the wrong place because this is going to be a YouTube video, but if you're hiding from the law, you might want to log out for a minute. But we're going to publish a picture of all of you, a still picture, as still pictures run deep. If you don't have a camera, well, I don't know. I'll sell you one. That's how we work, I guess.
all right.
I like the non-deterministic nature of the screenshot. That Brad presses the button and then it happens sometime thereafter.
Sure.
Let me know when I can pick my nose.
Anytime. Okay, for reference pictures of those who weren't participating, you might look on the website. Dave will maybe post to the chat the URL of the location of where these screenshots reside. He accumulates them on the website every month, and I'm very grateful to him for all of the things that he does for us.
Yeah, the screenshot will be posted on the meeting notes for this month, which have yet to be composed.
I understand, but it's in a directory that you might send to the chat, a URL. Or I'll find it and do that myself, because it is my expectation that any person of normal intelligence should be able to find it. Anyway, on with the show. Brad, before Brad starts, I wanted to ask how many of you would like to participate in the challenge, just out of idle curiosity for planning purposes only. All right. I expected Brad to, Brad put up his hand. Okay, good. And Armstrong, Bob, Bob is sort of raising his hand. He alleged that he could solve it in no problem in a cozy calendar.
Actually, I end up just putting the years and the dates, the days of the weeks of the two things up, and at that point, there's a discontinuity of 1 year in what I see, and I leave it up to you to actually go and figure out how the hell that works out. You know, I put enough.
So you'll talk a little bit and share the screen and present what you found, and it'll be
Yeah, it's
interesting
already
if nothing else. I wanted to take a minute to show folks an interesting little tchotchke. This is here. I'll do it after Brad speaks, because I'd like to hear what Brad has to say. But so Brad, introduce yourself and on with your talk.